Hi everybody, this is Mr. Raed Al-Nusayrat. Today, inshallah, we will continue in lesson 3.7, derivatives of exponential and logarithmic functions, unit 3, term 1. In this video, inshallah, we will talk for some applications for this lesson. And our learning objectives, it's find the derivative of exponential functions, find the derivatives of natural logarithmic function, and solve real-life problems using derivatives of exponential and logarithmic functions. So we will focus, inshallah, in this video about the last learning objective. Our keywords today, it's exponential function, natural logarithmic function, logarithmic differentiation, percentage rate of change, and relative rate of change. Example, if the value of 100 dirhams investment doubles every year, its value after t years is given by v of t equal 102 to the power t. Find the instantaneous percentage rate of change of the value. Which value? V of t. So I want to find the instantaneous percentage rate of change. First of all, I must find the instantaneous rate of change. Instantaneous rate of change as v prime of t, which is the derivative of v of t. Now, what's the derivative for 100 times 2 to the power t? 100 is a constant, so it will stay here, times 2 to the power t ln 2. This is the derivative for v of t, which is the instantaneous rate of change. After that, I must find the relative rate of change. The relative rate of change is the relative rate of change is the quotient between v prime of t and v of t, which is v prime of t, it's 100, 2 to the power t ln 2, over v of t, which is 100, 2 to the power t. Now, I can cancel here 100 with 100 and 2 to the power t with 2 to the power t. That gives me ln 2. Ln 2 equal 0.693. This value is the relative rate of change. If from this value I can find the percentage rate of change. Equal 0.693 times 100%, which give me 69.3%. In the second example, the concentration C of a certain chemical after T seconds of an autocatalytic reaction is given by C of t equal 10 over 9e to the power negative 20t plus 1. Show that C prime of t greater than 0 and use this information to determine that the concentration of the chemical never exceeds 10. So first of all, I will start from finding C prime of t. Now C of t equal 10 over 9e to the power minus 20t plus 1. From this function, I will find C prime of t. I will use now the rule for constant over function, which is negative of constant, so minus 10, times the derivative of denominator, which is 9e to the power minus 20t. Now the derivative of minus 20t is minus 20 times 9, it's minus 180. E to the power minus 20t, and derivative of plus 1, it's 0. So again, negative the constant in numerator times the derivative of denominator, which is 9 times derivative of minus 20t, which is minus 20. So minus 20 times 9, minus 80. And the exponential function e to the power minus 20t will stay. And derivative of plus 1 is 0. All of these over denominator square. 9 e to the power minus 20t plus 1 square, which is equal minus 10 times minus 180, it's 1,800 e to the power minus 20t over 9 e to the power negative 20t plus 1 square. This is the derivative for C of t. Now, this derivative is greater than 0. Why? Because numerator and denominator here both are greater than 0. Because 1,800 e to the power negative 20t is greater than 0, and 9 e to the power negative 20t plus 1 square also greater than 0. So value greater than 0 over another value greater than 0, positive over positive, all the time will give me positive. So here I explain why C prime of t is greater than 0. Now I will use this information to determine that the concentration of the chemical never exceeds 10. This concentration of chemical never exceeds the number 10. If I look here to the derivative C prime of t, C prime of t is greater than 0. That means the derivative is positive. What's the meaning of that? C prime of t greater than 0 for all t. That means all tangents line, all tangent line, all tangent lines have positive slope. So the graph of C of t it's increasing from left to right. So my graph for C of t is increasing all the time. Now, if I find the limit as t goes to infinity for C of t, this limit will give me limit as t goes to infinity for 10 over 9 e to the power negative 20t plus 1, which is equal 10 over 0 plus 1 equal 10. Because e to the power negative 20 times infinity, e to the power negative infinity will be 0. 0 plus times 9, it's 0. 0 plus 1 will be 1. So 10 over 1 will be 10. So this function, C of t, is increasing function, and the limit when t approaches infinity will be 10. That means C of t, concentration of the chemical, never exceed 10. C of t increasing, and limit t goes to infinity for C of t equal 10. So C of t never exceeds 10. Now we will go to another example. We will talk here about the motion of a spring. The motion of a spring is described by a function f of t equal e to the power negative t cosine t. Compute the velocity at time t. So the first thing, I will find the velocity at time t. After that, when, so he asked me about the time t. Is the velocity is 0. So when t, what's the value of t with velocity equals 0? That means v equals 0. And t is between 0 and 2 pi. After that, what is the position of the spring when the velocity is 0? So I have three things here. I will start from the first one, v of t. V of t is the derivative of f. What's the derivative of e to the power negative t cosine t? Here I have a product function, so I will use the product rule of derivative. Derivative of e to the power negative t, it's negative e to the power negative t times cosine t plus derivative of cosine, it's negative sine t times e to the power negative t. This is the velocity. When is the velocity 0. So I need v of t equals 0. That means negative e to the power negative t cosine t minus sine t e to the power negative t equals 0. Now take negative e to the power negative t as a common factor. I have here cosine t plus sine t equals 0. From this, cosine t plus sine t equals 0 only because e to the power negative t all the time, it's not be 0. So I will take this one only, cosine t plus sine t equals 0. What's the meaning of that? The meaning of that is sine t equal negative cosine t. Divide by cosine, so tan t equal negative 1. If I divide by cosine t. Which angles between 0 and 2 pi, the tangent tan t is equal negative 1. The first one is t equal 3 pi over 4. And the second one is 7 pi over 4. So the values of t makes the velocity equal 0. It's two values, t equal 3 pi over 4 and t equals 7 pi over 4. Now, what about the position of the spring when the velocity is 0? So I need f of t when v of t equals 0. V of t equals 0, I will take the first one, t equal 3 pi over 4, and find the value of f. I will substitute 3 pi over 4 in the function f of t equal e to the power negative t cosine t. Use your calculator here. So the value is negative 0.067. And when t equals 7 pi over 4, I can find f of 7 pi over 4 equal 0.003. So this is the position of the spring when the velocity equals 0. Say he will take this value 2 times in the first. The tangent line to f of x equal x squared times e to the power minus 2x is horizontal. So I need the value of x, make the tangent line horizontal. I will start from f prime of x. F prime of x is 2x times e to the power negative 2x plus x squared times derivative of e to the power negative 2x, which is minus 2 e to the power negative 2x. I can take e to the power, I can take e to the power negative 2x as a common factor. So I have 2x minus 2x squared. Now, slope of these tangents is f prime of x. And because I look for the horizontal tangents, this slope must be equal 0. So e to the power negative 2x times 2x minus 2x squared, I will take it as 0. The first term, e to the power negative 2x, this one cannot give me 0, so it's not equal 0. So I will take 2x minus 2x squared equals 0 and solve this quadratic equation. I can take 2x as a common factor. So here 1 minus x equals 0. So I have two values. The first one, x equals 0, and the second one, x equals 1. So the tangents will be horizontal when x equals 0 and x equals 1. Now, quickly recap for this lesson. For any constant a greater than 0, derivative of a to the power x is a to the power x ln a, and the derivative of a to the power x is a to the power x. Derivative of f of x equal a to the power g of x, it's a to the power g of x times g prime of x times ln a, and derivative of ln x is 1 over x. Also, the derivative of ln g of x is g prime of x over g x.